How to determine cycle time, required number of observations, sample size to find out what to set a standard. For example, we are studying, we're trying to figure out how much time it takes to do the oil change so that we can charge our customer appropriately. And this is applied in everywhere. Let's say you're trying to manufacture a piece of electronics. How much time is going to take to do that? Let's say you are trying to processing an water. How much time it takes to do that processing? And we do the costing or the amount of money it takes to do that based on the time it needs. So if you look at this oil change example, that let's assume that hypothetically it takes 20 minutes to do the oil change. Now, not every time it's going to take 20, it's going to be a little bit more or a little bit less. And this is that formula. So this is going to be that 20 minutes plus minus some error. This piece, this guy here. This is basically the same formula. We'll show this very soon in Excel, how to do all these things. So basically 20 minutes plus minus some error. Now, when you are doing oil change, it's going to be plus minus some minutes. Now think about, we are repairing an engine that requires overhauling the entire engine. So then it's going to be plus minus some hours because it will take hours. So this error term is basically some proportion of that mean value, some fraction of that mean value. So we can say that the error term here, which we'll explain in Excel soon, that is equal to the some portion of that x, and k is that percentile value. And then we can solve it for this sample size. Let's talk. So that's the formula we need to determine the number of observations needed to set the standard. Now we cannot start everything from vacuum. We have to have some kind of pilot study done. Let's assume that we'll show all this calculation soon in Excel. Let's say we did a pilot study of 25 car. It took 2 minutes to do the oil change. The standard deviation we calculated was 1.7 minutes. This t value, I'll show how to do it in Excel soon. And then this percentage of fraction of x is 5% here. If you plug all this number here, you will see that the 10 will sample size is 10. Now I calculated this for multiple different k values. Let me explain what that thing means. So this 22 minutes we have found from our pilot study. Now if we study only 22 cars. Now if the k value we use is so we found this sample size n equal to 10 based on k value 5. What that means is if we are almost 90%, 95% close to the actual thing. So you're only 5% away from the true mean. Now, if we want to be very close to that actual mean, let's say only 0.1% away from the true mean, 99.9% close to the true mean, then we have to study over 25,000 oil changes to set that standard, which is ridiculous. Most of the situation, 5% is good enough number. So we'll be about 95% close to the actual thing. Now, let me show you how to do all this calculation in Excel. So this is the data we have collected for 25 cars here. And then I generate this number using random numbers, so it will not same thing as we have seen in PowerPoint, but that's okay. So let's do a count function to find out our what's wrong with that? Count is C-O-U-N-T. I don't know how to spell count. So then select that. Degrees of freedom, in this case sample size -1. We're just emitting one thing, so that's sample size -1. X bar, we can write the formula in Excel called average. You know all that, so just going through the process. stdev dot s for samples. We are collecting standard deviation from sample. Alpha value always 0.05 in a statistical world. 0.05% is considered too low probability for something to happen. Do not change this value just to make your points. This is always 0.05. Now t value is very simple. Just to do TINV. Oh, I gotta put a equal sign before that. TINV, and then do it will ask for the probability. So this function will produce the actual t value, the length from the mean value from the probability, and using the degrees of freedom. Close that. So that's the t value. Now I got all this stuff I need for the sample size calculation formula. Let's write this here now. So equal to, we're going to start with the parentheses, t value. I'll freeze that because I want to use that same formula for all of these k values. So I'll freeze that, putting a dollar sign before and after e, times the standard deviation. I'll use this again and again. So let's freeze that as well. Divide by the k. Remember, k is here in percentage, but in the formula it should be in absolute value. So it's going to be this divided by 100. Then I'm not going to freeze that because I'll be calculating for all k value, and x is the x bar. Freeze that, close the parentheses, and then I have to square that whole thing. All right, here we go. So you can see here, to be 95% close to the actual value, we have to do about it's constantly changing because of the random number, but you get the idea how to calculate that. This is very simple, nothing to be worried about. A lot of time I see people do sample just by guess, random guess. Oh, we're gonna do 50 every 2 hours. It just costs extra and you're not accurate. So it's very, very simple, this formula. So I hope this explained how to determine cycle time, observation, number of observation needed to be studied, or sample size to set a standard time.